back. Today we're going to talk about more parallel lines and the angles that are formed. And today's focus isn't going to be on what it is, it's going to be on how do they relate to one another in order to prove some things. So this is an extension of kind of like a proof sort of thing. A couple of postulates just to knock these out of the way. We have talked about how when you have lines that are parallel, so they're already saying that they're parallel, certain relationships exist in those angles that are formed. Well, the converse is going to be where we're questioning whether the lines are parallel or not. And so when I'm given this example over here, where they've marked angle 1 and angle 2, still two lines cut by a transversal, still 8 angles formed, but we're highlighting 1 and 2, and we're saying that 1 is congruent to 2. The converse of the corresponding angles postulate says if corresponding angles are congruent, then lines are parallel. Which lines? Well, the lines that are not the transversal. Okay? And so we have to be able to recognize these relationships in order to know which lines would be parallel if they are congruent. And so these two lines now, we can say that they're parallel. We're proving that they're parallel by saying, oh yeah, the converse of the corresponding angles theorem says because corresponding angles are congruent, then lines are parallel. That's the gist of all these theorems today. We're going to establish relationships that we already know. Corresponding angles, alternate interior, alternate exterior, same side interior. We're going to establish those relationships, evaluate the angles being congruent or supplementary, and prove lines are parallel. And so when I look at this, I've got M and N, which are two lines that are cut by a transversal. And once again, angles 1 and 2, we're saying they are congruent. So we look to see how are 1 and 2 related. Obviously, they're alternate interior angles because they're opposite of the transversal, making them alternate, and inside the two lines cut by the transversal, and they're congruent. The converse of the alternate interior angles theorem says if alternate interior angles are congruent, then lines are parallel, meaning the lines that are cut by the transversal. So now we can say that these are parallel because the alternate interior angles are congruent. So remember, before we said they're parallel, so the angles are congruent. Now we're doing the converse of that, saying angles are parallel, or angles are congruent, therefore parallel. Same thing for the alternate exterior converse. Angles 3 and 4 are alternate exterior angles, and so if they're congruent, then lines are parallel. So we can now say that these are parallel, and I'm marking them with arrowheads, as you know. But how many pairs have to be congruent? Just one. There are two sets of alternate exterior angles. There's two sets of alternate interior. There are 4 sets of corresponding angles, but just one of them has to be in this criteria in order to prove that lines are parallel. Then from there, it follows that everything else about these parallel lines cut by a transversal is true. Let's talk about 5 and 6. If we look at 5 and 6, they are obviously related in a different way. They are same side interior angles. Same side of the transversal inside those two lines that we're trying to prove are parallel. So, if same side interior angles are congruent, then lines are parallel. So we can now mark these parallel because those same side interior angles are 180, given the fact that we're given this statement. Let's use this to try to solve a couple of problems. They're going to give you some pieces of evidence and ask you if it's reasonable to say that they're parallel. The first one that they give you is this diagram, and they say 1 and 5 are congruent. The question you need to ask yourself is how do 1 and 5 relate to one another? And if you look at 1 and 5, angle 1 and angle 5 are corresponding. And you should think to yourself, How do I want them to relate in order for the lines to be parallel? Well, corresponding angles are one of those sets that we want to show congruent. And so if they've given that it's congruent, we can say by the converse of corresponding angles theorem, L is parallel to M, because those are the two lines that form the 8 angles when cut by the transversal. In number 4, it's a little bit trickier because they don't actually give us what they want. They're adding a little bit of element of algebra in. So the measure of angle 4 is what we're talking about, and we're also talking about the measure of angle 8. And so immediately we should say angle 4 and angle 8 are corresponding. And we should think in our head, what do we want to show for them to be parallel? Well, corresponding angles, once again, need to show that those are congruent. And so they've given us this x here, and they've given us two expressions. What do you think we're going to do to show that 4 and 8 are congruent? We're going to plug it in. So let's do that. 2 times 65 plus 10 gives me 130 plus 10 gives me 140. So the measure of angle 4 equals 140 degrees. Think about it. What's reasonable? What do I need to show that 8 is? I need to show that 8 is going to be 140 as well. Let's do 3 times 65 minus 55. 3 times 60 would be 180. 3 times 5 would be 15, so that'd be 185. Or 180 plus 15 would be 185. Sorry, 195. You guys had it right. I had it wrong. 195 minus 55. 195 minus 5 would be 190. 190 minus 50 would be 140. So the measure of angle 8 equals 140. Well, what does that show? It shows that they're congruent. And I recall that they're corresponding angles, so now that I've shown them congruent, I can say by the corresponding angles converse, L is parallel to M. I'm providing a justification for why I can say that. Because I showed that the angles are congruent, the corresponding angles converse says that they are parallel. See if you can do this one on your own. It looks a lot like the previous example, and so I want you to try to look through and justify why you said what you said. So go ahead and do these two on your own. You're going to see that the process is very similar. Parallel postulate. Through a point P, not on line L, there's exactly one line parallel to L. Here's L, the world's least straight line. And so this is, the postulate is saying, if I draw a line that is through that point, I'm going to call it M, that's the only one that is parallel to L. So I can draw all these other lines, and they might even be pretty close, but only one of them can be truly parallel. Determining whether lines are parallel. Use the given information and the theorems, so those 4 that we've been given, to show that R is parallel to S. So I want to see if these two are parallel. I want to try to prove that. We're going to have to recall some relationships here. Let's look at 2 and 6. 2 is congruent to 6. Let's think about 2 congruent to 6 for a second. Well, if 2 is congruent to 6, I know that they're on a line, so the linear pair postulate says the measure of angle 2 plus the measure of angle 6 equals 180. So if they're equal, then measure of angle 2 equals 90, and also the measure of angle 6 equals 90. And so if I go around and I mark these, 90, 90, 90, I've got 8 90s here, right? So what does that tell me? If everything is congruent, then all of those theorems are true, because not only are corresponding angles congruent, therefore they're parallel, alternate exterior angles are congruent, so they're parallel, alternate interior angles are congruent, so they're parallel, and also same side interior angles are supplementary. So, by any theorem you choose, R is parallel to S. It's a beautiful thing. Let's see what we've got here. 6 and 7. I'll go in blue for this one. 6 and 7. 6 and 7 are same side interior angles. In parentheses, want to show. What do we want to show if these are going to be parallel? Same side interior angles. We want to show that measure of angle 6 plus measure of angle 7 equals 180. Well, let's look. Let's leave the x out of it for a second. Let's use a little bit of logic here. The measure of angle 6 plus the measure of angle 7 is equal to 6x plus 18 plus 9x plus 12. So let's add those together. I've got 15x plus, and 18 and 12 will be 30. What if I waited and substituted in x right now? Because I added those two angles together, they just happen to have x's in them. And I substituted in, I get 15 times 10 plus 30 equals 150 plus 30 equals 180. My conclusion is R is parallel to S because same side interior angles were congruent, were supplementary, sorry. That's all I've got for you right now, guys. I want you to try these last two on your own. Notice the relationships. Try to figure out how are they supposed to relate, and then see if they do. Thanks for watching. We'll see you next time.